Okay, good morning, dear lecturer and dear students. Welcome to my presentation today. Encryption and decryption of vertex, or in other words, electronic data, more generally. Firstly, I want to talk about my progress, what I have done until now. First, I did literature research. This took a lot of time of me because the subject wasn't familiar to me. And in the midterm presentation, I presented the VHDL design of encryption, just a second, and functional block design of encryption. I presented those two in the midterm presentation. And in the final presentation, today, I will present VHDL design of decryption algorithm and the functional block design of the decryption algorithm. And of course, there will be a demonstration. I want you to focus on some detail over here. As you see, the amount of time that I spent on each task decreases gradually here, because the same problem that I came up against here that I solved in the previous sections. Overview. Okay, I separated this slide into three separate parts. First, objective. I want you to remember the main idea of the project in objective section, and in decryption section, I want you to give details about decryption and the demonstration. Of course, I will show you the Quartus platform. Okay, let's remember the main idea. Okay, I have been dealing with designing a crypto system in my computer. This crypto system provides security. With security, we have a data. We want to send this data to another point, and this data must not unveil itself. Because of that, we need to encrypt this data and then decrypt this data. For this reason, we have to use a method, or a decryption or encryption method. I used AES algorithm, or in Turkish, AES, the Advanced Encryption Standard, and I programmed this AES on Quartus platform, and I simulated also. I wrote codes. I wrote VHDL codes on Quartus platform also. Okay, the crypto system is simply this. We have a data. We want to send this data through in an insecure channel, and we need this data to be secure, or to be hidden from another parties. Because of that, I have to design an encryption rule and a decryption rule. So let's see the input and outputs of the decryption algorithm. As in the encryption algorithm, we have 16 bytes of input data and 16 bytes of input data. Each byte consists of 8 bits. Okay, I will give you a general glimpse of the decryption algorithm, the functional block design of the decryption algorithm. Of course, you will see on Quartus program what I have done. I want you to focus on the inputs and outputs over here. For example, this ciphertext called input, we give the input from here to the algorithm. It goes to key addition layer, then mix column layer, shift rows, and byte substitution layer. We get the outputs 8-bit out. You see 8-bit outputs upside and 8-bit, I mean 8 outputs downside. You see. Let me explain key addition layer. In key addition layer, we operate on XOR operation. I mean, we do XOR operation in key addition layer. The input to the key addition layer is first the key. The 108 bits of key is fed into the key addition layer, and also the ciphertext is fed into the key addition layer. Then we get the output. Inverse column mixing, we do the inverse matrix multiplication. But for example, in encryption algorithm, we did the matrix multiplication in forward direction, and we need to do inverse multiplication in this section. For this reason, we need to take the inverse of the matrix. And this is my block design of the mixed column mixing layer. And I designed this layer as 108 bits of input and 108 bits of output. And row shifting, if you remember in the encryption, we did left shift, but in this layer we will do right shift. We will do the opposite of what we have done in the encryption. And those inverse row shifting, those are inverse row shifting design of my VHDL codes and the block design. And again, you see the 108 bits of input goes into the box, and I separated the outputs because I need to distribute them, each of them, to the X boxes. In byte substitution layer, it's the simplest one, I think. We only need to choose values from X and Y pairs, and we will just match it. For example, 1 and 1 goes to E3. So of course, those are hexadecimal numbers. Again, this is my this is the VHDL design and block design of byte substitution layer. And my references in here, I also thank Marian Golevsky from Białystok University Technology for his endeavor, for his thoughtful endeavor in my. I mean, he supplied me with the devices, and he taught me the FPGA and VHDL in my Erasmus program. Okay, let's directly pass into the demonstration process. Do you see my screen? Quartus platform? Okay, that's nice. You see the encryption algorithm here. And over here, the decryption algorithm you see. First of all, I will encrypt some text and then decrypt. I just want to grasp an intuition about this. For example, I will double click shift row column, and it gives me the VHDL code behind those. Each block consists of VHDL codes behind them, inside them more. Okay, let me show you an example. I already prepared one. Let's, for example, you see the A columns all the way down to the ciphertext over here. Those are our inputs, 0, 0, 0, and I presented only one. I changed only one input here. For example, I can show it in hexadecimal form. 52, for example. Let's encrypt this data, this column. Okay, we encrypted this data and we get this ciphertext. Of course, those are a bunch of zeros and ones. I want to show it in hexadecimal form. Okay, this is more convenient. Right now, I will copy this ciphertext and I will directly go to the encryption algorithm. Decryption algorithm. Here, I want to paste over here, and I want to decrypt this text right now. Okay, right now you see in W5 output the same output, output that we fed into the input encryption algorithm. I will show it in hexadecimal number, of course. Right now, 52. You see. Of course, we can fill the other inputs in the encryption section, but it takes too much time. I will do only this one. Just a second. Well, where is the encryption? Okay. Okay, this is the encryption simulation. We see A552, and of course this is hexadecimal number. And in decryption, we get this same, and we successfully encrypted and decrypted an electronic data. Thank you for listening.
Thank you, Yusuf. Your approach is a little different than Serhat's approach, I see. You are more going with the binary or hexadecimal representation of numbers or letters. But I think one problem in your study, in your work, is the time. It takes too long time to convert the whole page maybe into the coded form. I don't know how it will take, but it's a good work, and you have learned, I think, too much think about coding and encoding.
Of course.
But in the real-time coding problems, the algorithm should run a little quicker, because nowadays, we are using sometimes encoded telephone, and when we are speaking to the telephone, or when we are sending some picture through the WhatsApp, they are encoded quickly and then they are transmitted. But it's good study. Thank you for your presentation. And now we have 2 minutes. Okay, 2 minutes. Then after the junction will stop, and I will have 5 minutes break then to have your teas, 5 minutes, and then I will record the presentation, first pre-presentation, and we will start the new presentation at 10:45. Okay, it's good. 10:45, and we will start with Sena. Now we are stopping at 10:45. We start again with Senam's presentation. Okay. Now, Yusuf, make me host again.
Okay.
Okay. Now, at 10:45, see you.